So picking up on Unit 4B on atmospheric circulations, we have looked at the Rossby waves a little bit, and I recommend you have a peek at this 2.5 or 3 minute animation about those. And now let's go to the next point, and that is that when we have these changes in the Rossby waves, what we're seeing are more extreme droughts, floods, heat waves, even Arctic air invasions and lower latitudes. In the dips, persistent wet weather, and if in the winter, cold. So if you're here, for example, it's drier here, and if that's summer, it's hot. Winter, not necessarily, but usually warmer than average because it's tapping in moisture from down below here. But on the other hand, if you're over here, it's wet and cold, nasty weather in the winter and early spring or late fall. And we did have some jet stream dipping that influenced some of the hurricanes down in this region the last several summers and even into the Houston, Texas area, where these hurricanes literally just parked for 2 or 3 days in one spot and dropped like 50 inches of rain, which is kind of hard to imagine given that in the Mid-Willamette Valley we get about 40 inches of rain a whole year. Imagine getting that much in 2 or 3 days. So these are very extreme kinds of weather and also droughts. So the western U.S. is in a record drought, and the central and eastern U.S. is in a record wet spell. I'm going to show you some stuff on that later on. So these are interesting times. We are finding a new climate. It really is just new. And just going back to remember this, this is really driven, it's believed, by a warming Arctic, which makes the kind of equator polar temperature differences less. So, briefly, this is a cross section to just kind of review some things, but we haven't looked at it quite this way. You did have some earlier graphics that were a bit like this, but just to kind of show you this, there's all this rising air near the equatorial low, and it sinks. Oops. Some of it makes it into the kind of the polar region here. Some sinking going on here. A large part of it sinks over the subtropics. That's the subtropical highs at about 30 degrees north and south. So this would be the equator, and then there's 30 degrees north or south, and then all the way to the poles here. So we have that sinking, and then the trade winds returning. So you have this kind of cycle here. We have the westerlies that are colliding with the polar air here, the polar easterlies. So you have a couple jet streams, and either one of these can be different, but it seems like the northern jet stream is the one that seems to be altering the most in this story. So just looking at them this way, a lot of times there are two branches, the polar and the subtropical. And in the polar particular area, the winds can be pretty strong, upwards of close to 200 miles an hour during the peak winters when that's usually strongest. All right, so deep breath. So time to move to a new topic. And if you're a outdoors person, the kind of stuff I'm going to show you now might help you understand the world that you're coping with and enjoying maybe a bit. If you're a hiker, if you like this backpacking, camping, hunting, fishing, whatever it is you're into. And so local winds are not the big, global scale winds, the westerlies, the trade winds, the polar easterlies, none of that. These are winds that are generated in smaller areas. And so they're defined as winds that develop due to local surface differences in heating and cooling. And they develop best in otherwise clear and calm conditions where daytime solar radiation input or nighttime terrestrial radiation output are maximized. So if you have a clear night, you can have really strong radiative loss, cools the ground off rapidly. Or during a day, if it's clear and otherwise calm, the sun comes in unimpeded and warms up the surfaces dramatically. So those are the perfect conditions when in some places, if the geography is right, they can develop what we call local winds or breezes sometimes. So there's some types. The simplest one, the kind of classic one in almost any physical geography or meteorology textbook, are sea breezes. Sea breezes happen when interior areas heat up more than the adjoining surfaces and wind blows on shore. So you're at the beach, it's summer, and maybe it was calm in the morning, and let's say it's sunny. The beach heats up faster than the ocean nearby, and rising air over the beach pulls in air from the sea. So that's a sea breeze, and these are always named to the direction they come from. So what if it's cloudy? So if it's cloudy, the interior areas typically won't heat up more, as much rather. And so the temperature difference, which really drives the pressure difference, which drives the breezes, is less. So a clouding in of the interior area can usually slow these down, depending on the setting, but often that's the case. Land breezes can happen in exactly the same geography, but they go the opposite way. If the sea breeze blows on shore during the day, the land breeze, when you have strong nighttime radiational cooling, makes the surface cooler than the adjoining areas. And so what forms is a high pressure cell over the land and somewhat lower pressure over the sea. So you get a kind of offshore flow. Another kind is a thermal, or sometimes they're called upslope winds that happen during daytime surface heating of the slopes. Movement is then upslope. And so these are especially pronounced in late spring, summer, early fall. The same environment can see those winds reverse at night and come down the hill when you have that efficient nighttime radiative cooling, and it makes for a cold, dense air along the slopes, and that cold, dense air flows downhill, kind of like water flows downhill. And in doing so, pretty much it takes the opposite route as it did during the day. So these tend to be nighttime and then maybe the very early morning until it starts warming up significantly. And so these can happen any time of year, but we think of spring, summer, and fall as being the most common times. But there are some places where, like, we have glaciers making mountains really, really cold, and say have cold air coming off them too. And they can flow down slope, or katabatic flows down slope. Valley winds flow up valleys into heated adjoining mountains, while in the same environments, there's a reversal where the nighttime mountain winds flow downhill and down valley, and the heating mechanisms described in the thermals and the katabatic or drainage winds are in play there, but the geography is a little more complex. So let's have a look at that geography. If you look at the bottom slide here, you can see rising air going up these sides of a valley into the hills. So then the air comes from the valley and goes up toward the mountain. Okay, so there's this kind of removal of air in the system, and it pulls it up. The same environment with clear nights, good radiative cooling along these slopes, so that cold air under the force of gravity flows downhill, and then it all joins up in the valley itself, and then you'll get a big volume of air come down the slope, and you've got a very persistent wind there on a clear night. I grew up in where there was a slope not this steep, but definitely a slope about 5 or 6% past our house. And every night in the summer, we get this wonderful breeze that would blow, and it would basically cool our house off at night. So we would just open our windows up at night and shut them in the morning when we went off to work, and we had air conditioning. In only a few days did it get very uncomfortable. Now, there's a whole narrative here that I'd like you to read. I won't read through it with you, but you might want to just pause here and read this. It gives you a little bit more thorough description of what I've just described. All right, so if you've got sea breezes, which is when the air flows from the sea to the heated land, that would be more of a high sun thing. And then you've got land breezes when the continent is especially cold near oceans, you can get big wind reversals. And that's what monsoonal wind systems are. Now, when you saw that word monsoonal, you probably thought what? My guess is you thought, oh, this is a setting where we have big rains, the monsoons, right? And that's largely accurate. But the stricter definition is just that these are places where you have big seasonal wind changes. And those wind changes are because of reversals in the temperature gradients from onshore to offshore. So when you have onshore movement from the sea is cooler than the land, and when you have the opposite direction, the sea is warmer than the land, and so it goes offshore, flowing from cold to warm. Always cold, sinking air, higher pressure, flowing offshore, that kind of thing. So when you have summer onshore circulations from very warm oceans, you have rain. So monsoonal climates are known for kind of the tropical downpours, incredible volumes of rain, that sort of thing. South Asia comes to mind. Winter, the offshore circulations are observed where the cold continent and the warmer ocean nearby. The air flows from sinking air over the continent, that will be high pressure. It flows offshore, and this is typically much drier, of course, because the air comes over the continent and off rather than from the warm and moist ocean. So where? So places to remember: Southeast Asia. So all the islands in like Indonesia and then Vietnam onshore, Thailand, and then in South Asia, India, Pakistan, Bangladesh, that sort of thing. Those are monsoonal lands. Equatorial Africa, basically right straight at the equator there, and West Africa especially is that way. And then a bit of the South American Amazon has a what we would call a monsoon climate, where you have big seasonal wind reversals. Those are the main areas of the world. We have more minor kinds of shifts in other places, but these are kind of the classic monsoon climates. Especially, we think of it as South and Southeast Asia. And we're going to see in a minute here. Let's go down there now. In fact, look at this map here. It shows us kind of some big numbers of 40 plus inches a year of rain in a lot of these areas, and some areas get to even hundreds of inches in the mountains up in this region here along the Himalaya. Very, very, very wet places. So going back again, yeah, so the summer Asian monsoon. That's what I've got for you. So hopefully this was useful.